video, I'm going to show you some coordinate geometry exam questions. If you find any of them particularly tricky, have a look at my playlist on coordinate geometry where I break down the topics individually and go into a bit more detail. So in part A of this exam question, we have to calculate the coordinates of points A and B. So points A and B are the intersections of the straight line with the circle. So because we're trying to work out the coordinates of points of intersection, we're going to solve the simultaneous equations. We have the equation of the straight line and also the equation of the circle. And the equation of the straight line is rearranged so that y is the subject. It says y equals. So I'm going to replace the value of y in the equation of the circle with 3x minus 20, as then I'll have an equation with only x as the unknown, which I can solve for x. Okay, so I'm going to start by substituting this into here in place of y. So when I do that, I get x plus 1 all squared plus 3x minus 20 minus 2 all squared equals 85. Okay, so I'm just going to simplify and expand the brackets and try and solve this equation for x. So I'm going to start by expanding these brackets here. So that gives me x squared plus 2x plus 1. I'm just going to simplify what's in here before I expand the brackets. So I have negative 20 take away 2 is negative 22. And next I'm going to square these brackets here. Okay, so this part just stays the same for the moment. And if I expand these brackets, I get 9x squared, negative 132x, and plus 484 equals 85. Okay, so then I made a mistake there. No, that's looking good. Okay, so next I have to just simplify this. I'm going to add all the like terms together. So 1x squared plus 9x squared is 10x squared. If I add 2x to negative 132x, I have negative 130x. And positive 1 plus 484 is 485. Now I'm going to move this 85 over to the left-hand side, so I'm going to subtract 85 so that my quadratic equation is equal to 0. So I have 10x squared minus 130x plus 400. Okay, and I can see that there's a common factor here. I can divide everything in the equation by 10 and it leaves me with x squared minus 13x plus 40, which is looking much simpler to solve now. Okay, I can actually factorize this. If you can't see that the equation can be factorized, you could use the quadratic formula to solve the equation, but this one can be factorized. So inside the brackets, these two numbers here have to multiply to give positive 40 and add to give negative 13. There should be negative 8 and negative 5, okay? So that gives me my two x values, positive 8 and positive 5, okay? So we can see here that the x coordinate of A should be 8 and the x coordinate of B should be 5. So next we have to find the corresponding y values, okay, to go with each of these x values. So we're going to one by one substitute these values into this equation up here for the straight line, because this is much simpler than substituting into the equation of a circle. Okay, so let's start with substituting x equals 8 into this equation here. So I'm just going to switch my x value to 8 so that y is equal to 3 lots of 8 minus 20. Well, 3 times 8 is 24, and if I subtract 20, I'm left with 4. So there's our y value when x is 8. And now I'm going to change the x value to 5, so that y is equal to 3 lots of 5 minus 20. Well, 3 times 5 is 15, and if we take away 20, we get negative 5. So just to summarize at the end, the coordinates of A should be positive 8 for the x value and positive 4 for the y value. And then for B, the x coordinate was 5 and the corresponding y value was -5. So they are the coordinates of A and B. So in part B, it says find an equation of the circle which has its centre at C and for which the line with the equation y equals 3x minus 20 is a tangent to the circle. Okay, so the centre of this new circle is the same as in the first diagram at C, but the radius has changed. Okay, they've told us that this straight line, y equals 3x minus 20, is now a tangent to the circle instead. Okay, so it's going to intersect the circle in one place instead of two. Okay, so the circle would look something like this. Okay, so let's start by working out what the centre of this circle is. Okay, and we can do that by looking at the equation of the circle, which is up here, and it's written in its completed square form, so it's easy to find the centre. Okay, the centre of the circle is found by looking at these numbers here inside the square brackets. So the x coordinate is this number here in the x bracket, but the opposite sign. Okay, so -1. And the y coordinate is this number but the opposite sign, so +2. Okay, so that's the centre of this new circle and the old circle as well. Okay, now the equation of the new circle is going to look very similar to the previous one, x plus 1 all squared plus y minus 2 all squared, because the centre is the same, but we don't know the radius. Okay, the radius has changed, so we don't know this value here, r squared, the radius squared. I'm just going to put it equal to k. Okay, it's some constant that we don't know. Okay, now because the straight line is a tangent to the circle, and so we know they intersect in just one place, when you find the simultaneous equations of the equation of the circle with the equation of this straight line, if you find the discriminant, you know it has to equal 0, okay, because they intersect in one place. So that's what we're going to do. We're going to solve the simultaneous equations here, okay, find the discriminant and put it equal to 0, and then hopefully there we'll be able to solve this problem, okay? So I'm going to, like before, switch my y value to 3x minus 20 in this equation down here, so that I have x plus 1 all squared in this bracket, and then over here it's going to become 3x minus 20, take away 2 all squared equals k. Okay, so I'm just going to try and simplify this. So I'm going to start by expanding these brackets here. So I have x squared plus 2x plus 1. Here I'm just going to simplify this before I expand. So inside the bracket it should be 3x minus 22 all squared. Now I'm going to expand these brackets again and simplify. So x squared plus 2x plus 1 plus 9x squared minus 132x plus 484 equals k. Okay, so I'm just expanding the brackets and simplifying. So now I'm going to collect all the like terms. So I have x squared plus 9x squared, which is 10x squared. Here, if I add 2x to negative 132x, I have negative 130x. And here, if I add 1 to 484, I have 485. Okay, so before I can find the discriminant, I need this quadratic to equal 0. So I'm also going to move my value of k over to the left-hand side. So now the equation is 10x squared minus 130x plus 485, take away k. Okay, so remember the discriminant is b squared minus 4ac. Well, here's my value of a, 10. My value of b is negative 130, and then my value of c is all of this, okay? The constant, the part without the x's, okay? So let's substitute those values into b squared minus 4ac. So that b squared is now negative 130 squared minus 4 lots of a, which is 10. And multiply that with c, so 485, take away k. And remember, I said the discriminant has to equal 0 because the straight line is a tangent to the circle. So all of this has to equal 0. Okay, so now we're trying to solve this equation to find the value of k. So all I'm doing from here is expanding all the brackets of the discriminant, simplifying, and then solving this equation to find k. So if I square negative 130, I get 16,900. Then if I multiply negative 4 by 10, I get negative 40. And if I multiply negative 40 with 485, I get negative 19,400. Then if I multiply negative 40 with negative k, I get positive 40k. Okay, so I'm trying to solve this equation for k. So I'm going to move these numbers over to the right-hand side of the equation. Okay, so that I isolate k on the left-hand side. So I'm going to subtract 16,900 and add 19,400. So that gives me 40k is equal to 2,500. And then all you have to do at the end is divide both sides by 40. So k is equal to 62.5. Okay, so there's our value of k. So remember, what we're actually trying to do is find an equation of the circle. And remember, we worked out the centre at the beginning, so we had most of the equation, but we didn't know this value here. Okay, but we just worked out the value of k. So the last step is just to substitute this into the equation that we wrote here. So the final equation would be x plus 1 all squared plus y minus 2 all squared, and it's equal to 62.5. And that's it. So in the next exam question, it says the equation of a circle is x squared plus y squared plus 6x minus 2y minus 26 equals 0. And in part A, we have to find the coordinates of the centre of the circle and the radius. Hence, find the coordinates of the lowest point on the circle. Okay, so if you need to work out the coordinates of the centre of the circle and the radius, it's a good idea to write the equation of the circle in what we call completed square form. Okay, so I'm just going to rewrite the equation down below, but I'm going to write the x terms next to each other and the y terms next to each other before I complete the square. Okay, so it's going to look like this. So x squared plus 6x plus y squared minus 2y minus 26 equals 0. Okay, so I'm going to complete the square first looking at the x terms. Okay, so I need my square brackets and I'm going to fill in the x value. Remember, to find this number, you have to take the coefficient of x and divide it by 2. So positive 6 divided by 2 is 3. And then you have to subtract this number squared, so I'm going to subtract 9. Now I'm going to do the same thing with the y terms. So I'm going to add my square brackets, fill in the y value, take the coefficient of y, so negative 2, divide it by 2, so I get negative 1, and then subtract this number squared. So I'm going to subtract 1 squared, which is 1. Okay, and not forgetting to subtract 26 and put it equal to 0. Okay, so now I'm just going to simplify this. I'm going to add these numbers here together. So I'm going to leave the square brackets as they are at the beginning. So x plus 3 all squared plus y minus 1 all squared. Now negative 9, take away 1 is negative 10, and if you take away 26, you have negative 36. And then I'm going to move that 36 over to the right hand side, so it's going to change to a positive. So the equation of our circle is written like this in its completed square form. Okay, so the centre of the circle can be found by looking at the numbers inside these square brackets. Okay, so the x coordinate is in this bracket here. It's this number but the opposite sign, so it's going to be at negative 3. And the y coordinate of the centre is this number over here but the opposite sign, so positive 1. So they're the coordinates of the centre of the circle. Now when the equation is written in completed square form like this number here, this constant, is equal to the radius squared. So if 36 is equal to the radius squared, you have to square root it in order to work out the radius. Okay, so the square root of 36 is r, the radius, which is 6. Okay, so we've done the first part, we found the centre coordinates, and then here is the radius 6. So in the next part, we have to find the coordinates of the lowest point on the circle. So I think it's helpful just to draw a rough sketch of the circle, just so you can visualise what you're actually trying to do. So here's the sketch of the circle, and I've plotted the centre of the circle at minus 3, 1. Okay, so the lowest point of the circle is found here, okay? And we know the radius is 6. So the distance from this centre point to the circumference is always 6. So if the y value of our centre is at positive 1, the y value of this lowest point is going to be 6 units below. So if you subtract 6 from the number 1, you get negative 5. So that is the y value of the lowest point, okay, on the circle. Now to find the x value, you need to substitute your y value back into the equation of the circle, and then you can solve to find the value of x, okay? So I'm going to change the y value to negative 5 in this equation here. So my equation becomes x plus 3 all squared plus negative 5 take away 1 all squared equals 36. And it doesn't matter if you substitute the values of y into here, okay, you'll get exactly the same answer for x. Okay, so let's work this out. So negative 5 take away 1 is negative 6, and if I square that, I get positive 36. Okay, and it's equal to 36. So if I subtract 36 on both sides, they cancel, and so the equation is now x plus 3 all squared is equal to 0. So if this square bracket is equal to 0, this value of x has to be equal to negative 3, because negative 3 plus 3 is equal to 0, and 0 squared equals 0. So the x value is negative 3. So that is the lowest point on the circle. So in part B, it says find the set of values of the constant k for which the line with the equation y equals kx minus 5 intersects the circle at 2 distinct points, okay? And I've just rewritten the equation of the circle here in completed square form from earlier. So because the circle and the straight line intersect at 2 distinct points, I know that the discriminant has to be greater than 0, okay? So I'm going to solve the simultaneous equations using the equation of the straight line and the equation of the circle, okay? And from that resulting equation, I'm going to find the discriminant, okay? And then I'm going to put it greater than 0 and solve the inequality, okay, to find k. So I'm going to replace the y value with kx minus 5 in here, okay? So the equation will now look like this. So x plus 3 all squared plus k x minus 5 take away 1 all squared, and that is equal to 36. Here, minus 5 take away 1 is minus 6, so I'm just going to simplify that bracket first. Okay, and now I'm going to expand and simplify these brackets. Okay, so if I expand the first bracket here, I am left with x squared plus 6x plus 9. Over here, I have k squared x squared minus 12kx plus 36, and that is equal to 36. I'm just going to subtract 36 on both sides, so they cancel. And now I'm just going to group my x squared terms together and my x terms together so that I can identify A, B, and C to be able to calculate the discriminant, okay? So I'm going to put the x squared terms at the front, and I'm going to factor out the x squared at the same time so that I can see the coefficient of x squared is 1 plus k squared, okay? So I've just grouped these two terms together and I factored out the x squared. It's exactly the same thing. I'm just writing it in a different way so that I can see my value of a here. Okay, now I'm going to do the same thing for my x values. So I've got positive 6x and negative 12kx, and again I'm going to factor out my x value. So here I would have positive 6 and negative 12k. So this is my value of b. And then c is the constant, okay? All the terms without x, so it's just this one here, positive 9. Okay, and it's equal to 0. So the discriminant is b squared minus 4ac. Okay, so if I take my value of b here, I need to square it. So this is my b squared. Minus 4 lots of a, which is 1 plus k squared. And multiply that with c. And remember, this is the discriminant, and this is going to be greater than 0 because the straight line intersects the circle in 2 places, okay? So I'm just going to carry on up here and expand and simplify again. So if I expand these brackets here, I have 6 squared, which is 36, Then I have 6 multiplied by negative 12k is negative 72k, and another negative 72k. Then if I multiply this by itself, I get positive 144k squared. Then if I multiply all of these brackets out here, I get negative 4 multiplied by 9, which is negative 36. Then I have negative 4 multiplied by k squared, and then by 9, which is negative 36k squared, and this is greater than 0. Okay, so I'm just simplifying. So here I can see there's positive 36, take away 36, that goes to 0. Here I've got negative 144k. And then if I have 144k squared and I subtract 36k squared, I'm left with 108k squared. And remember, this is greater than 0. Okay, so I can divide everything by 36, okay, in this expression. That is the common factor. So this is negative 4k and this is 3k squared. And so I'm solving this quadratic inequality, okay? So what you can do from here is you can factor out the value of k. So inside the brackets you would have 3k minus 4. Okay, so if you did a sketch of this quadratic, it would intersect the x-axis at either 0 or positive 4/3. And because this quadratic is greater than 0, we're interested in everything above the x-axis, so these parts. So from there, you can see all the values to the left here would be k is smaller than 0, or all the values here to the right of 4/3, so k would be greater than 4/3. So they are the set of values of the constant k. So in this question it says the equation of a circle is x squared plus y squared plus ax plus by minus 12 equals 0. The points A at 1, 1 and B at 2, minus 6 lie on the circle. Find the values of A and B and hence find the coordinates of the centre of the circle. Okay, so we're trying to find the values A and B here in the equation of the circle, and we've been given 2 different points A and B. So I'm going to substitute the x, y coordinates from each of those points into the equation of the circle one by one, and that will help me form 2 separate equations, okay? Then I can use those 2 equations, I'm going to solve simultaneously to work out the values of A and B. Okay, so I'm going to start by substituting these coordinates into the equation. So x is 1 and y is 1. So when I do that, instead of having x squared, I have 1 squared. Instead of y squared, I have 1 squared again. Then if I times a by 1, I just get a. And if I times b by 1, I have positive b. Not forgetting to subtract 12 and put it equal to 0. Okay, so I'm just going to simplify this equation. So I've got a plus b here. Then 1 squared is 1, so 1 plus 1 is 2. And if I take away 12, I have negative 10. Then if I move the negative 10 over to the other side of the equation, it changes to a positive 10. So this is equation number 1. Now I'm going to substitute the other point, these coordinates, into the equation of the circle. So this time I need to change the x values to 2 and the y values to negative 6. Okay, so instead of x squared, we've got 2 squared. Instead of y squared, we've got negative 6 squared. Then we're timesing a by positive 2, so that's 2a. And then we're multiplying b by y, so b with negative 6, so that's negative 6b. And then again subtracting 12 and putting it equal to 0. Okay, so I'm just going to simplify this equation and rearrange it so it looks like this one up here. So 2 squared is 4, negative 6 squared is positive 36. Everything everything else just stays the same for the moment. Okay, and now I'm going to add these numbers here together. So 4 plus 36 is 40, and then if I take away 12, I get 28. And if I move the positive 28 over to the other side of the equation, it's going to become negative 28. Okay, one more thing I'm going to do here, just so it's a bit simpler later on, is I'm going to divide everything by 2, as there's a common factor here. So that leaves me with a minus 3b equals negative 14. Okay, so next, this is equation 2. I'm going to solve the simultaneous equations, and I can see that by subtracting these two equations, the a terms will cancel each other out, okay, and then I can solve for b. So I'm going to take equation 1 and subtract equation 2. Okay, so if I do a take away a, these are going to cancel. If I do b take away negative 3b, it's the same as b plus 3b, which is 4b. And then if I do 10 take away negative 14, it's the same as 10 plus 14, which is 24. Okay, and if I divide by 4 on both sides, I find that b is equal to 6. Okay, so now to find the value of a, you just have to substitute this value of 6 into either of these equations. So let's just take this one up here. So instead of a plus b, I've got a plus 6, because b happens to be 6, and this is equal to 10. So if I subtract 6 on both sides, I find that a is equal to 4. So they are my values of a and b. So we just worked out that the values of a and b were 4 and 6. So what I'm going to do now is I'm just going to substitute those into the equation of the circle up here. So the equation is x squared plus y squared plus 4 lots of x because a is 4 plus 6 lots of y because b is 6. Okay, and that is the equation of the circle. So if we want to work out the center coordinates of this circle, we need to write the equation of the circle in its completed square form. So I'm going to start by writing the x terms next to each other. So x squared plus 4x, and then the y squared terms, the y terms next to each other. So y squared plus 6y. And now I'm going to complete the square. First, looking at the x terms. So remember, you need square brackets. You can fill in the x value here. And now this number is half of the coefficient of x. So positive 4 divided by 2 is 2. So here we have positive 2, okay? And then not forgetting to minus this number squared, so minusing 4. Then if I do the same thing with the y terms, so you have your square brackets, you fill in the y value. This number here is half of the coefficient of y. So positive 6 divided by 2 is positive 3. And then you would minus this number squared, so minus 9. And then minus 12 equals 0. So this is the equation of the circle in its completed square form. So if you want to just simplify at the end, so put the square brackets next to each other. And then negative 4, take away 9, take away 12 is negative 25. But if you move it over to the right hand side, it changes to a positive 25. Okay, so this is the equation of the circle rewritten in completed square form. Now this is useful because we can now spot the center of the circle. Okay, the center of the circle, the x coordinate is this number here, but the opposite sign, so negative 2. And the y coordinate is this number here, but the opposite sign, so negative 3. And if we were asked for the radius, I know they don't ask for it in this question, it would be the square root of 25, which is 5, okay? So there is the centre of the circle. So in part B, it says find the equation of the tangent to the circle at the point A, giving your answer in the form px plus qy equals k, where p, q and k are integers. Okay, so it's helpful if you can just draw a rough sketch, okay? I think it's much easier to figure out what you need to do when you have a sketch. So here is the circle from earlier, and remember we worked out the coordinates of the centre, okay? The centre lies at minus 2, minus 3, okay? So here's the sketch with the tangent at the point 1, 1. Remember, a tangent is just a straight line that touches the curve in one place and it touches the curve at the point 1, 1, okay? So we're trying to work out the equation of this straight line, okay? And to be able to work out the equation, we need to know the gradient and the y-intercept, and at the moment we don't know either of those. We do know that the tangent and the radius are perpendicular to each other, and if you multiply the gradient of two perpendicular lines together, the two gradients, you always get -1. So if we can work out the gradient of the line AC, from there we can work out the gradient to the tangent, and then we can work out the equation. So I'm going to start by working out the gradient of the line AC. Okay, so to work out the gradient, I use a method called rise or run. I find the difference between the y values, and then I divide by the difference in the x values. So the y values are here, so 1 and -3, and I have to subtract them. So 1 take away -3, and then I divide by the difference in the x values. So 1 take away -2, and if I work that out, I get 4/3. Okay, so that's the gradient of the line AC. So the gradient of the tangent is going to be -3/4, okay? The easiest way just to remember how to work out the gradient is the sign will always change if the line is perpendicular like this, and then you find the reciprocal, so the fraction will switch upside down. Alternatively, you could divide -1 by 4/3 and it would give you -3/4, okay? Because remember, these two gradients have to multiply to give -1, okay? So now we have the gradient of the tangent, and we also have one point that lies on the tangent, 1, 1. So using that information, we can work out the equation. So I'm going to write down y equals mx plus c. Okay, so this is just the general form for the equation of a straight line, and I'm going to substitute in the value of y, which is 1, so a point on the line. M is the gradient, so -3/4, and our x value is also +1. And then plus c, we don't know yet. This is going to be the y-intercept, okay? So let's work this out. So 1 multiplied by -3/4 is just -3/4. So 1 is equal to -3/4 plus c. And so I'm going to add 3/4 to the other side. So c is 1 3/4. So that's the y-intercept of the tangent. So if I group it all together, the equation is going to be y equals -3/4 x. Because remember, the gradient is -3/4 plus 1.75. However, we have to make sure that we write the equation in this form, and P, Q, and K have to be integers, and at the moment they're not. So what I'm going to do is I'm going to multiply everything in this equation by 4, okay, as that will give us the integers that we need. So y multiplied by 4 is 4y. -3/4 multiplied by 4 is -3x, and if I multiply this by 4 I get +7, and then all I need to do is move this -3x over to the left hand side of the equation, so that 3x plus 4y is equal to 7, and that is the equation of the tangent.